be okay. We're live now.
Oh, cool. Um, yeah, so for question number 2, it says given a 90% confidence interval for a mean heart rate, which of the following is the best interpretation of this confidence interval? And I think it is number 2. We are 90% confident that the true mean heart rate is between 45 and 105. Does anybody else remember? I think that was lesson 10, lesson
Oh
9.
wow, we have 32 questions today.
Yeah,
Yeah, it's gonna be a
yeah, no,
lot.
this is a review for the exam.
Jeez. Okay.
So what do you guys think? Number 2, right?
Yeah.
Um,
Okay. All right, let's go on to number 3. It says the researchers decided to construct a confidence interval to determine if the difference of the means is significant. To determine whether the confidence interval would be reliable, they create a QQ plot of both random samples and they see that they are approximately normal. Are the requirements for constructing a confidence interval satisfied? Why or why not? I believe it's not because if you go up above for additional information, it says the researchers randomly selected 20 females and 15 males to participate. So it's the first one. The distribution of the mean of each sample is not normal since the sample size is not large enough.
okay.
Okay.
All right. Mhm. Turn that off. My face is ugly right now. Of the 4 types of confidence intervals listed below, which one is the most appropriate for this experiment? This one I don't know. I guess number 4, but
Have you
that's
already
just the
taken the
best
quiz,
guess.
Niall? Have
What was that?
you already taken the quiz?
No, I was actually on. I was like starting on it, and then you called. But yeah, I only got to number 5.
All right. 4 types of confidence.
I just did a best guess because I really don't know which one it would be.
One of the word. Um, I think that's right.
Because is the sigma known?
Niall,
I
what
don't
did you
know.
say that you thought it was again?
I thought it
Well,
was
if
number
he,
4, but
yeah,
I
he thought it was 4, right?
Uh-huh.
but that's just for this specific experiment. Like, I guess it's just asking like what parameters do we want for a confidence interval. Well, I'm
I don't know.
not exactly sure, but I'm gonna go with that. Um, you
Okay.
guys can go ahead and put down what you can. Question number 5. A researcher is interested in estimating the savings account balance of a customer at a large bank. She obtains the savings account balance of a random sample of 30 customers. A 95% confidence interval for the mean savings account balance of bank customers is found to be 3,402 and 8 cents. And so that's the lower bound, and the upper bound is 4,142 and 75 cents. Which of the following would produce a confidence interval with a smaller margin error than this 95% confidence interval? Um, error.
Mm.
If we increase the sample size, that actually makes the denominator bigger, which would create a smaller sample size. So I think it's number 4. Obtain the balances of 90
Yeah.
big customers rather than 30.
Yeah, I was just gonna say that.
Okay. A factory makes propeller shafts, drive shafts for ships. A quality assurance engineer at the factory needs to estimate the true mean and length of the shafts. She randomly selects 4 drive shafts made at the factory, measures their lengths, and finds their sample mean to be 1,000 millimeters. The lengths are known to follow a normal distribution whose standard deviation is 2 millimeters. Calculating a 95% confidence interval for the true mean length of the shafts. Input your answers in the margin below. Well, how do we figure this one out without any information?
I think that we have to pull up that Excel sheet.
Oh, because
Yeah,
does that?
I was just looking at that.
You put
And
up
it
the
doesn't.
confidence interval, you put in the sample mean and the standard deviation.
What's the sample
Put
mean?
in the assumptions that they give you.
They just the sample mean and the standard deviation and the confidence interval. It doesn't give us a. Doesn't give us the sample size.
No.
Which? So you think we put it into one of the Excel sheets?
Yeah, like
No.
No, because we don't have enough information, right?
Nope.
I
no.
always think I understand
Well,
this stuff
we can
until
get
they
the sample
do
size
this.
formula with what we have. I'm pretty sure. Because we have the z-score, which is, what is it at 95% confidence? It's 1.96.
1.96.
Okay. So that's 1.96 times 2 millimeters divided by, oh, except for, wait, M is margin of error, right?
Yes.
Dang. So we need the margin of error to find the sample size. Well, it's tough. Do you think it's just 30? Oh, just kidding. The sample size is 4. I totally missed that. That's weird. Why would it be 4? Anyways, all right, so we have the sample size. Margin of error is, let's go ahead and do the math. Al, you want to double check with me?
I'm just saying
Okay,
mine.
so what formula is that again?
It's going to be the M equals z-score times sigma divided by square root of n.
Okay.
So it's going to be 2 divided by 2, 1. So it's going to be 1.96.
Yep, that's what I got.
Huh. Weird. That's super simple. Input the lower bound.
I got 998.04
Wait, for which?
for the lower.
99.8?
998.04.
How'd you get that one? Oh, you did the formula, never mind. And what did you get for the upper bound?
1001.96.
Ah, gotcha. All right. To assess the accuracy of a laboratory scale, a standard weight that is known to weigh 1 gram is repeatedly weighed, not wailed, a total of n times, and the mean of the weighings is computed. Suppose the scale readings are normally distributed with an unknown mean mu and standard deviation sigma is equal to 0.01 grams. How large should n be so that a 95% confidence interval for mu has a margin of error of plus or minus 0.0001? The formula for this one is what was it? So n equals z-score times sigma divided by m, all of that squared. So we have 95%, 1.96 times 0.01 times 0.01. Okay, and then that divided by the margin of error. Okay, divided by 0.001. Oh, that's squared. Ooh, that's a huge number. Allie, what did you get?
I'm still working on it.
Okay, because I got like 38,000.
Um,
Pretty sure that's not right.
I just finished it. That's what I got. I got 38,416.
Oh, so you got that too.
I think that that's correct.
All right.
'Cause
Wow.
in other,
It's a rather large number, but yeah.
yeah. Well, I thought the same thing, but in a homework quiz we had like 2 weeks ago, I got a huge number like that, but it was
Okay.
correct. I can't remember what my tutor said.
Well, no, it makes sense because if you want the margin of error to be 0.0001, you would have to have a rather large sample size.
Yeah,
So that does
that's
make sense.
hardly any. Yeah.
All right.
So you got 380416?
No, 38416.
Oh, 38416.
Yes, ma'am.
0.38416
No, just 38,416.
for question 9.
Yep.
Okay.
Let's see. The mean area mu of several thousand. This is question 10, by the way. Sorry. Several thousand apartments in a new development is advertised to be
Oh,
1,250
wait,
square
sorry.
feet.
I completely missed what 11 was.
Oh, we're on 10.
We're on 10.
I thought you said 11. Sorry.
Y'all good. A tenant group thinks that the apartments are smaller than advertised. They hire an engineer to measure a random sample of apartments to test their suspicion. The appropriate null and alternative hypothesis, HO and HA, are blah, blah, blah. So they're just
It's the
wanting to
last
know if
one,
it's
isn't it?
smaller.
Yeah, so it's the last
I
one.
took the last one.
Yes, looks like it. Question 11, is the statistical test of hypothesis. We say we reject the null hypothesis with the level of significance sigma. I don't know what that is. Sigma? Alpha? No, that's alpha.
Yeah.
If the p-value
Is
is
less than.
larger, less than, yes.
Is it
That's
less than?
true. Yep.
Wait, if P is low.
Yeah, if p
Yeah.
is below the alpha.
Yeah.
Question 12, a group of did
Sorry.
everybody get that?
11 was B.
2.
It was B.
Yeah.
Just making sure I heard correctly.
A group of statistics students wants to determine if students in some apartment buildings get better grades than students in other apartment buildings. They collect GPAs from an anonymous random sample of size 15. From each of 4 different apartment buildings. The data for each apartment building are bell-shaped with no outliers, and the sample variances are nearly equal. Can they use an ANOVA hypothesis test to answer their question? Isn't the whole purpose of an ANOVA test is to try and find that they're the same rather than trying to find out if they're different.
Yeah, because I thought that was like they're either all the same or one of them's different.
I mean, that's the purpose of an ANOVA, is to prove that it is the same. Well,
Well, I guess let's see.
or they do not know the true standard deviation. Well, sure, you know the standard deviation. They do not have enough data. I'd be inclined to say they don't have enough data, personally. Just because they don't have 30. What do y'all think?
Yeah.
Yeah, I
Because we
agree.
could say that it is enough data if it's bell-shaped with no outliers,
Yeah, we could say
and the
that if
sample
they're
variance
because
That's what I think it is.
yeah,
I'm putting.
I think it's that one.
Which one?
The number 3, the yes, it is enough.
Okay, because I feel like that one would be fine. It's just sometimes like you have these laws and like you can't ever go against them, like real
Right.
life.
But I think it says if those conditions are met, then you can do it, and both of those conditions would be if those conditions would be met. I guess. I don't know.
Oh, you know what? You're right. Yep, I remember reading that. Okay, so we'll go with number 3 then, or the C, or whatever. Question 13. A medical researcher is working on a new treatment for a certain type of cancer. The average survival time after diagnosis is 2 years. It's enough time to go on a mission. So the null hypothesis is the average survival time after diagnosis is the same for the new treatment and the standard treatment. In an early trial, she tries the new treatment on 3 subjects who have an average survival time after diagnosis of 4.5 years. Even though the sample is small, the results are statistically significant at the 0.05 significance level. Consequently, she rejects the null hypothesis. In a future study, it is determined that the new treatment does not increase the mean survival time in population of all patients with this particular type of cancer.
Oh,
The
what is this?
researcher has committed.
What type of error?
Well, if we think about it, and do like the 4 boxes or whatever,
Yeah.
I believe it's a type 1 error.
okay. All I know is
Okay, I'm
that-
looking. I found the box thing right here. So if we fail to reject, so we're rejecting the null or failing to reject? She rejected it, right?
we rejected the null, but it turns out that we should have failed to reject the null.
Yeah, so it's a type 1.
Okay. So rejecting the null when the null is true is type 1,
Mm-hmm.
correct?
I think so. That's what it says.
Okay. Perfecto.
If I'm reading it correctly.
Okay. If the level of significance alpha is made very small, thereby making the probability of committing a type 1 error very small, what happens to the probability of committing a type 2 error? By reducing the probability of committing a type 1 error, we also reduce the relationship between them. I think it's A.
I think it is too.
Okay. The nicotine content in cigarettes of a certain brand is normally distributed with a mean in milligrams and a known standard deviation 0.17. The brand advertises that the mean nicotine content of its cigarette is 1.5. I don't know why you'd advertise that, but anyways. But measurements on a random sample of 100 cigarettes of this brand gives a sample mean of X bar equals 1.553. Is this evidence that the mean nicotine content is actually higher than advertised? To answer this, test the hypothesis. Null is 1.5, and alternative is greater than 1.5. at the 0.05 level of significance. You should conclude that well, if we have all the information here, we have a sample size which is 10. Let's see, what do we got? Mm-hmm. So X bar is 1.53, right?
Mhm.
Okay. So we have 0.03 divided by. What was S? S is standard deviation, right?
Yes.
Yes.
No, S is standard deviation of the mean. I'm pretty sure. Huh.
Oh, I'm trying to remember how to do it.
Oh, maybe I'm just trying to do students' t distribution when I shouldn't be. Anyway.
Okay, so we're doing.
Anybody know which formula to use?
That's what I was just trying to figure out.
Well, we can't do any formulas with the z-score in it because that doesn't make any sense. I'm pretty
Unless
sure we're
are we
supposed to
trying
do
to find a z-score?
Oh, we are?
I don't know. Because all the other ones have the z in them, right? Well, n doesn't, but we already know the sample size.
It's true.
So is it z? Is the formula the one that z equals x bar minus
Yeah,
the
yeah, we
mean?
want that one.
Okay, so it's z equals 1.53 minus the mean is what? 1.5?
Mm-hmm. So X bar is
One
1.53 and then U is 1.5.
minus 1.5 divided by 0.17 and the square root of
You say 1.7? Oh, 0.17?
oh, 0.17 is the standard deviation.
Minus 10? That makes it
No, so
negative.
oh, you're right.
I
Because the
don't know. I
square root
just
of
don't think
110.
that's right.
I don't know.
I think there's a different formula, if I'm not mistaken.
You
One that
probably
you
are
just
right.
find the z-score with. So if I had to guess, do you already know the margin of error?
No.
Oh wait, we have z-score. Z-score is 1.96. What's going on here? Oh man, I gotta go back to lesson 10. Let's see here. What's the formula for this segment? Da-dum, da-dum, da-dum. The heck is going on here? Weird.
Let's see here.
Crap. What? Why is it so hard to remember how to do this?
I don't know. I can't. It's like
Because this
it's
is
like
like
I
the
look.
most basic thing of proving a hypothesis.
I look at this and then think, did I learn any of this?
Oh, I know I did. I just can't remember
I
which
I know I
formula.
did, but I can't seem to remember. So do you think it's less than 10?
Oh, we're trying to find the p-score, right? The p-value right now.
Yes. So to do the p-value, don't we have to put the z-score into the applet?
I think so.
So what is the z-score though? Didn't
And
we
we
have
want
to
to know if it's greater than, right?
Yeah, don't we have to compute the z-score though?
Well, I think so. What is it? It was 1.96?
Well, that's the isn't that isn't it
looks like the p-value is
1.767?
0.025.
What? 0.025?
I think so. Because if you put in, well, let's see here.
I'm looking back here.
I mean, we already have the z-score.
Yeah.
Oh, okay.
All I know is that we want to get the p-value. So how do we do that?
I'm looking through my notes here.
I think it's we reject HO or whatever sigma. I don't even know the terms.
Yeah. This is just really weirding me out that I don't remember this.
I know I'm going to need a serious refresher before I take.
Me too.
Well, if the standard deviation is 0.17, that doesn't make any sense. All right, well, we're going to have to keep going because I know that you don't have much time. Question 16. You would like to look at the mean number of hours worked for wages per week by male students and female students. You would like a random sample of 100 for each group and test if those means are different. What is the correct statistical procedure? Well, it'd be a two-test. Would it be paired? No.
No,
They
because
don't really affect each other, so it could be independent, but that's not a thing, is it?
yeah, samples are independent as a two-sample t.
I know, but it should say two-sample t-test instead of independent samples t-test. Or no?
Oh, true.
I'm thinking a t-test or ANOVA. It's not paired because paired means that they affect each other.
Right.
And it's not one sample because there's two samples. So I'm either why would it say independent? Why wouldn't it say two-sample t-test?
I don't know.
Well, I'm going to have to go with
super
ANOVA then
weird.
because I don't know what an independent samples t-test is.
We're on 16, right?
Yeah.
Yeah.
I put an independent samples t-test.
Well, that would make sense, but
that's just
why isn't it called two samples t-test?
Unless they're trying to throw us off and know
That's
which
what I'm
one's
saying.
wrong. Because all these other ones aren't right, because it's not a one sample. They're not paired. It's not three samples.
Whereas ANOVA, you're trying to test the mean difference.
Because ANOVA, you have to have three or more groups, and we only have two groups.
I think it's ANOVA because it's asking, because it wants to test if the means are different.
Yeah, but ANOVA, I'm looking at that flow chart she gave us, and ANOVA has to have three or more. And they're only using, that's what it says. It says three or more groups. And this is two groups.
More.
All right.
So
well,
we just
let's
need to
go
decide two
independent.
groups. If I think that's right, independent.
Earned
That's so
it.
weird that they would name
Go
it
with
that.
An educator is interested in academic achievement by males and females with similar academic support systems. She decides to use brothers and sisters, raised in the same home. Furthermore, she decides to use only brother and sister pairs when they are next to each other in sibling order. Makes sense. Should she use a hypothesis test based on independent or dependent sampling? Definitely
So it's
dependent. I mean, there's
and
no
it's the
way.
last one, I think. Dependent sampling, if you select a brother so as to compare his academic achievement to a sister,
Yes.
you also have to include the sister.
Exactly. All right, next one. A soil scientist collected random sample soils from a field and measured and dissolved organic carbon. The measurements are recorded, and we'll have to download that one. Very fun. A researcher would like to construct a 95% confidence interval for the mean. Dissolved. Of the 4 types of confidence intervals listed below, which one is appropriate for the situation?
Okay, so let's look at this.
Well, with the data that we have, we can know the mean and we can know the standard deviation. It's not hard.
Well, it only gives you one.
What kind
It's
of
got to
test does he
be,
want?
well, it's got to be one with one group because there's only one group. The data
Right.
only gives us. So is the sigma known or unknown?
Well, sigma should be known. I mean, we can get it easy from the data.
Can't we look?
I'm going to go with C.
I put the first one for 18.
Determine the margin of error for this 95% confident interval. That's not going to be hard. Equals average fetch. And then it's standard deviation sample, right?
Mhm.
STDEV.S.
Mhm.
I think so. I have the mean as 13.193 and the standard deviation as 4.325. 4.326, really. And put your answers for the margin of error, lower bound and upper bound. Okay.
Okay, so I'm catching up to you here. I
I
got
mean,
it
if
in
you
there
guys
though.
remember that formula for margin of error, M equals z-score. Z-score is 1.96. So sigma is, let's see. Did it say sample size? Oh, we didn't do sample size. Oops. My bad. Sample size is 20. So let's see what we have here. And it's square root. No. Yeah, it's the square root. Okay, so 4.3258 divided by 20 square root. So 0.967 times 1.96 1.96. I have 1.89. $1.896. Has anybody else done the math yet?
Well, are you trying to do the confidence, determine the margin of error? Which one are you on? Are you on 18 or 19?
Margin of error, I
I'm
got
on 19.
the margin of error.
So
I got 2.0255.
I got
Is
two.
that you?
Okay, let me do it again.
Is that Andrea or is that Allie?
Because to do the margin of error, you take the upper bound, subtract by the lower bound, and divide by 2, right?
Right.
Huh. I
15.217.
guess you're right about that one. I was just doing the formula z-score times sigma divided by square root of n. But yeah, it's
Yeah, I got
gotcha.
2.0245, but we could do 2.0246. Is that what you guys got?
I did 2.0255. But I don't know.
Huh. I didn't get that
How
same
did you
thing. Let
guys
me
do
try
it
it again.
again?
You do the upper bound, a confidence interval upper bound, 15.217, subtracted by the lower bound,
Wait, how'd you get those?
11.168. I
Oh, did
put
you stick
the
that in that one thing?
data into the thing.
Oh, gotcha.
And then I got that's 4.049. And then if I divided by that by 2, I got 2.0245.
And we agreed on doing a
Oh, but you're right. But we're rounding up. I always screw up that. So it's 2.0255, right?
Okay. Oh, that sounds about right. 2.0 what?
2.0255.
26.
No,
2.026, right?
I put 2.0255.
2.025. Well, I mean, it's not like she's going to get you wrong. I just know that
No.
it's
I don't think that they mark you wrong if you
yeah.
don't
What was
ask.
the upper bound again?
The upper bound is 15.217.
217?
Uh-huh. And the lower bound is 11.168.
Wait. 2.17 you mean?
15.217
Yeah.
is the upper bound.
For upper bound?
Yes.
15.217?
Uh-huh.
And for
And the lower
bound?
bound is 11.168.
Okay, sweet. So 11.168, 15.217. All right, well, let's go ahead and go to 22. And I guess we'll have to download used Hummers.
Oh, that's what you were doing. Dang it. 15.2. I'm sitting there saying those numbers to you and then not actually typing it on my quiz. Okay. 21. Oh.
We want to know if there's a difference in the mean listing prices between Hummers for sale in Los Angeles and Hummers for sale in New York. Create a 95% confidence interval for the true difference of the mean listing prices. So this is, I'm pretty sure, a two-sample t-test. Of the 4 types of confidence intervals listed below, which one is appropriate for this situation? Man, I don't know. Why does it keep asking us this crap?
I don't know. Doesn't make any sense to me.
The confidence interval for the difference of means using independent samples. I'm pretty sure, so 3. Calculate the 95% confidence interval for the true difference of the mean listing prices.
All right, so we got to do a 2 sample. They're not paired though, right?
No, they're not paired. So it's 2 sample. But what does it mean, the true difference of the mean listing prices?
I'm not sure. I'm getting the
'Cause
data
that
in
doesn't
here.
make any sense.
Oh my. Are we?
That's what I'm saying.
What are
what's the
we
difference in
comparing? We're
prices?
comparing price.
Yeah.
Oh my word! And there's tons of stuff in here. Ugh. All right. Copy. Okay, so I have the data in there. Now what are we looking for?
Well, we just care only if it's not equal to, right? It's just asking if there's a difference.
Calculate the 95% confidence.
Looks like
So
different sample sizes. Sorry. All right.
are we on?
Calculate
Are
95%.
you on 22 or 23?
I'm on 22.
So aren't we finding the confidence interval for the differences of means using independent samples? Because that's what
Wait,
our
what?
data is, right? Isn't it the number 3, confidence interval for the difference of means using independent samples?
Number 3?
Yeah. I mean, question
Oh,
22,
yeah.
the
Yeah,
third
yeah,
one
yeah.
down.
22 is 3. And we're on 23 now, sorry.
Oh, okay. So 23
So
wants to know
input
the
the
lower bound.
bound.
And I have it as negative 423.238. Is that what you guys
Same
got?
here. 423.238.
Okay. And then the upper bound.
I have that as 5,417.336.
Yep, that's what I got.
What did you say? 5,000 and what?
17. 5417.336.
Yep.
Oh, that was
I
it?
got,
That's all we needed for that silly question? Is that?
I guess.
Yep. Okay. Now we have to get new.
Many studies have suggested there's a link between exercise and healthy bones. I hope so. Exercise stresses the bones and causes them to get stronger. One study examined the effects of jumping on bone density of growing rats. There were 3 groups. Rats were selected at random for 3 groups: a control with no jumping, a low jump group, a jump height that was 30 centimeters, and a high jump group of 60 centimeters. After 8 weeks of 10 jumps per day, 5 days per week, the bone density of the rats were measured. The data is recorded, obviously.
All right, so this we have to do an ANOVA.
Oh, great.
Which is such a pain. I'm starting to put it in. Do we have to do a QQ plot or anything dumb like that?
Yeah, did you guys figure out how to do the Q plot? Because that one's still hard for me.
If you watch that video she posted yesterday, I think, where she explains how to do it, it's so much better than the textbook. And so, like, I have a Mac, so you
did
can't.
watch it.
You
just
can do
haven't
the
done it yet.
Yeah, you can do the QQ plots. You have to go to that other Excel sheet, the what's it called? The descriptive statistics. And then if you go to the quantitative descriptive statistics Excel sheet, and then you click on QQ plot on the bottom, then you can put your data in. You put your data in, and then you have to sort it. But then you have to do it for each individual thing.
Gotcha.
And so it's kind of a big pain.
Well, I just put in the data for exercise bones or whatever.
Yeah, that's what I'm doing.
I have this test.
I am gonna have to go to work.
Oh, sorry.
It's okay. I can finish the quiz on my own.
All right.
Okay.
Well, have fun at work.
I'm just gonna have to end this and post it because I don't think unless you guys can.
That's fine.
Okay.
Thanks. Have a good one, Ellie.
Bye.